Hello and welcome to the instructions for how to set up automated wheel rotations using expressions along a motion path that actually can absorb the scaling or extension of the curve. So what we've done thus far is we've created a CV curve. I'll do this from the top view. I think it's a little better that way. So we have kind of a simple curve that we've drawn, and this curve does not unfortunately have a readily available bit of information telling us the length of it. So when we create a polygon primitive, in this case I'm just going to be doing a cylinder because it's going to be the easiest way, just this sort of naked wheel, if you will. Rotate it upright and bring it off the ground. And then I group it to itself because I need that Y rotation group. So these are the bare basics, sort of like the primitive setup of what we've done thus far. And because the rotation of the wheel can be automated according to when we affix it to the motion path, its value of, and let's just do it quickly here, sort of the U value of its completion along that path, we are able to come in and grab it, the motion path, and use this U value for the completion. And we can put that into a rotation value for the wheel, which is pretty good. We've done this before, and it works nicely. The problem comes up when we take this curve and we scale it, and or we come up here to go to the modeling window, go to curves, and actually can add points along it, sort of add to the curve. The problem is, because these are different lengths now, you can't actually, the rotation value that you have 0 to 1 is not going to work anymore. See, it's moving along the path, this wheel is moving along the path as I add points, because all these points are still calculated between frames 1 and 120, which means it's going to actually happen faster because I have a longer distance for it to travel. But I've also kind of compromised the rotation of this wheel. And one of the easiest ways for me to see with something this simple is to just grab 3 faces and take a bite out of it like a wheel of cheese, so I can see this sort of Pac-Man roll from a distance a little easier. And this is just for the purposes of our setup. So we've made this thing roll previously and it works just fine. All we do is we come into the expression of the rotation that we need, determine the direction of the rotation we need first, rotate Z, then we can come up here, control, right click on it and go immediately to expressions, and we can use this for tie this into the motion path information, and we can grab that, of course, coming in once we have this value here. We can come into the motion path, go to expressions, and this is the value we want to power this. And we copy that over, and then we're trying to use a multiplier of something like, say, 20 or 10 or 5 or something like that. And once we create it, the wheel actually rolls. It doesn't apparently roll very well. But we do have sort of a, well, that's right, it was more along the lines of 2000, wasn't it? So now we have more of a discernible roll, and it's going in the negative value. Oops, and jack this up to around 4,000. So let's see what we get there. Okay, a little more of a roll. So the thing is, this works, but it works for this length. Okay, so let's say that if this works nicely along this path, and it looks like it's a nice, modest path, good rate. If we start adding more and more to the points of the curve, we've extended the length of this curve, and this roll is not going to work because the calculation is specific to the length, is unique to the specific length of this curve. And we may want to add points, we may want to do whatever. Even scaling it just this is enough of a compromise that that calculation could no longer work. So see that? It's just not, it's not tracking. So what we want to do is actually tie in another consideration on top of our existing calculation for that rotation, which is we want it to be to use a multiplier of the length of this curve. Now Maya doesn't normally track the length of the curve, but there is a Mel script, really quick little bit of coding we can use to put one in, and this will create a node that will actually track the curve in real time and give us the length of the curve at any given moment. And I've actually also written this up here so that people can quickly come in and take a look at the command. So create this node first, select the curve, and run this, which is arclen, which is arc length. And then we want to turn it on to creating a node that will track it. And yes, my text file is called Bunny Fufu. So we come in here to grabbing the curve, go into your script editor, again, this icon down here, or you can come up here and go to script editor as well. Script editor is right here under general editors, script editor, same thing. Make sure you're in the Mel tab, not the Python tab, and paste arclen ch true. And if you run it, it should give you result 1, no errors. You can't really see it here in the outliner because it's an invisible node, and nodes are not readily apparent in the outliner. However, you can come up here to display, click on display, and turn off DAG objects only, and you should be able to come down here and see that you have now curve info. If you you can double click it and it'll tell you nothing, but if you come up here to the attribute editor, you can actually select it and see that the arc length is now being calculated in real time. So if we scale this again, well, that's sort of irritating, it popped out. So what we can do here is copy the tab. That means it's going to pop up a copy of this tab, but it's not going to change when I select something else. So this is the usual attribute editor. What I've done is I've copied the tab so that this is permanent. It'll stay on the curve editor, stay on the curve info node when I select something else. So watch this. This will change on the right. This will not change on the left. So I select the curve, and it gives us the update on the curves. As I scale it, notice this number of the arc length going down. And when I scale it up, notice the arc length coming up. So that's an attribute we want to use in our calculation. And that is here, curve info 1. So we are actually going to use the MotionPath ZU value, which is what we're already using. And we're going to use it in tandem with a get attribute, curve info, plus arc length. So let me just explain this briefly. In fact, I may want to just kind of bring it down to a slightly more reasonable size so that you can see it all at once. So the P cylinder rotate Z is already using the MotionPath value. I multiplied it by 3,000. I forget the number exactly. But what we haven't done is we have not actually used it alongside, and this is, by the way, is not going to be plus. That's silly. It would be multiplied by. So let's see what this does when we plug this in. So again, the MotionPath value here, only now we're going to multiply it by the length of the curve. And since this is this new multiplier is going to have quite an effect on the overall number, we may want to chop down the MotionPath multiplier first. So basically, this is just saying we want curve info 1, which means you're going to have to be specific if you have a setup where you've made other curve nodes. You need to make sure you have the right one. So this example is specific to our setup here. However, if you make something more complex later and you're using more curve information nodes, you need to change the name, otherwise it won't find it. And it's looking for the specific attribute of the curve info node, which is arc length, which we see up here. So that's the name of this. This is sort of maddening in that you can try your little expression trick, which is grab it, hold down the control key and right click, and it does not take you to the attribute editor. And even if you were to go to the attribute editor now, the expression editor, it doesn't actually list the attributes here. So you're like, well, I need this information here. What do I call that? Arc length? I don't know. So it is a little cagey, and this is sort of found the expression, well hidden, that allows you to grab that attribute and utilize it. So let's see just what this does, because again, we've added a new multiplier. So I probably do not need as grand of a number here. I think I have 4,000 in mind. So let's have a go at this. Let's go up to the expression editor for this existing expression. And I'm going to come over here and just kind of paste everything that we have because I don't need this value. I need to take my existing value, which works just fine, and just start going parentheses crazy with it and seeing if this works. It seems to work, only I've gotten an astronomically large number here, and that's probably because this 3,000 no longer applies. It's probably more around 30. I don't know. Let's have a go at it. Okay, it seems to be a reasonable roll there, which is nice. I could probably get away with maybe 25 if we're going to be picky, and we are. So yeah, okay, that's all right, actually, 25. So here we are. We have the expression that we're using for finding out the arc length using the curve info node. And within the curve info node, you have the arc length information for this specific curve size. And it looks like this little cheese wheel is doing a good bit of rolling here. It looks like it's tracking on the ground. And if I grab the curve, now I can scale it up or down, and its roll will be commensurate to the size. So it works when it's that small, and if I scale it up much bigger, the roll still tracks on the ground. It's going to move a lot faster. Again, it's got the length, and it's got a longer way to go, but it still tracks according to the size. So watch the arc length go down as I scale this down, and the expression's written so that that wheel should be commensurate to the size with which this curve is. In fact, it will come in here and we add some add points to it. It should still track. And there we are. I'll just hit play. So yeah, looks like it's doing all right. In fact, I just want to play it a little slower. There we go. So that's an expression you can utilize to get further the intelligence and the automation of your car, so that all of the malleability of your track does not necessitate you going in and having to change a hard-coded number. There you are. Enjoy.